Today's topic is we have understood the different services that the Spring Cloud provided, right? So today's topic about how the Spring Cloud can be integrated with the Kubernetes. So the community has started a project called Spring Cloud, okay, and that project has been uh, now currently part of the Spring Cloud. So whenever the cloud native or which application need to be put into different cloud platform, they have a certain need that you normally find, right? One is service discovery, one is externalization of configuration, preparation for failure or circuit breaking, load balancing, and routing, right? So these things are basic need for your application. So previously, when you had like monolithic applications, we don't need to delve into this. Okay. Now, so obviously these things can be done by your cloud platform, and that can be your main cloud platform like your Microsoft Azure, GCP, and AWS. Also, you have like Cloud Pivotal or Tanzu that has been created. Okay. Also, you can host this in the bare metal, and you can resolve the same thing by running the Spring Cloud into your on-premise services. So normally we find the different service provider provide load balancing, they provide DNS name resolution, service discovery, configurations, routing, security. All those details have been taken care by them. API gateway, etc. Normally, what happened in the big cloud applications for these things, we basically set up as we have seen previous demos that we have seen the service discovery, which is the separate service discovery service, config service, which is linking that particular data from the gate or RabbitMQ, and your applications or your front facing application or your edge services are having load balancing circuit breaker or tracking that is basically is a part of your cloud gateway. And your normal application you have a tracing involved. Same now these applications when deploy on the any big application deploy on the Kubernetes. The Kubernetes has its own load balancer because the definition of service itself is a load balancer, and every services that you create, which you deploy in a certain instances into multiple pods to replicate that, each of those applications has a service definition, and those service definition take up your load balancing. Similarly, in Kubernetes, you have a config map, which can be storing the configuration in the environment variable or in the volume. When the application starts, it reads from that particular volume and read the data. And there you can have the circuit breaker tracing in the part of your application. Now, what are the challenges that we face on the Kubernetes? Because here you have the Kubernetes specific services or specific features that enable cloud loading without depending on the Spring or any other framework, right? So how the Spring application can be integrated with the Kubernetes? So that means same config server which currently support from a particular path by file based watching, or it support your own load balancing. But here what happened is, platform Kubernetes, there are certain configuration you can change or algorithm for load balancing you cannot control as an application developer, right? And similarly, it has been taken care by the DevOps, how the configuration is mapped. So normally what happens is when the configuration gets changed, what we normally do, we just rolling deploy the application so that we gradually the pods are being removed and new pods with new config map, they can be able to read it. But we preferably we having like as a Spring developer, we wanted to use the services that like configuration refresh, those kind of features. So that will require to be integration with the Spring and Kubernetes itself. Okay. So in that case, what happen is we have to have this supports for Kubernetes to be in. Okay. So basically here in this picture, what happened is your service A request going to service B, they are going to the load balancer, circuit breaker, everything is no difference, what is the service we get it from. And we'll work up those HTTP requests of circuit breaker itself, and it is out of the box is supported, and you can normally also configure the tracing, etc. Uh, Maybe there are some downside out here that when you're doing these things this way, like I mentioned, the configuration point of view, right? We cannot refresh the config map change. You have to go to change the value and dynamically you have to load. That is not being supported. Okay. So now how the configuration is supported. So let's see what are the equivalent of the Kubernetes equivalents are there. So config server, if you can review here, they have equivalent services. They are like config maps and secrets, which are equivalent to your config server, and and you can configure maximum of your secret that you are there. Similarly, for your load balancing, it has been taken care at the service level, and also it is act as a registering a particular pod. So here, what happened is that your normally, if you use Eureka or some other service discovery from the Spring Cloud, the pod or the application instance itself goes down, goes to the particular HTTP request, make a HTTP request, and register themselves. Here, whenever the new pod instance has been created, the service instance itself act as a discovery server. So it holds the detail of that particular pod where the application is running or the container is running. So they support in the discovery service. And discovery client and other piece of functionality that is there, whenever the service located, etc., request has been made, they basically made to by the DNS of the service host. So, so DNS part of the service host detail that is stored, that is basically from the HTTP request like my service name, from the service name from the configuration during the deployment, those details are need to be used. And post and host name will be different for the particular environment, right? So you need to override this. If you are running this in a Spring Cloud without Kubernetes, outside the Kubernetes, obviously you have given your own service names into your Spring Cloud config, Spring application configuration. But here the different DNS names need to be used when you are using the discovery client, right? So there you can, override using the environment variable. Right here, the environment variable are Redis master server host, port, and then master port, TCP port, port TCP protocol, port address, TCP address, etc. So all those details that are there. So you have to override those service names that you have given. So basically from the environment variable inside the container, you can figure it out. What is the particular IP address, etc. So you can, instead of, IP address, you can directly give the service name and you can make the call. So all these values need to be modified. Now, how the Spring Cloud Kubernetes integrates with that? So Spring Cloud has community project, it has been started. So initially, when the Spring Cloud community project has been started, as we know, the Kubernetes has a control plane and the data plane, right? Control plane, you have the master server plus and the API service through which you can connect with CLIs or through REST APIs you can connect, or even a ID, and you can change the configuration or deployment or service definition of the individual Kubernetes structure. Okay. So now previously when it started, right, they basically all the service, the Spring Boot application service need to be integrated or make a call to the API server. Now, as they obviously any kind of modification require the API server, but it need to be integrated previously, the older version, it need to be integrated, or that permission to call the API service was need to be exposed to all the pods, right? All the services. Now, so in that case, what happened is basically DevOps team doesn't want that access to be very limited for the API server, because API server is a sensitive API which can able to change your Kubernetes cluster. Okay. So instead of how we can support the configuration update, right? So they have like created a config watcher which checks the K8 API server. If there is any configuration change request comes in, right? Then they can send a request, read the request, check that there is a change is happening, and then they send the request to a bus, something like a messaging system, right? RabbitMQ, and that message will be read by the individual pods, and then pods can read the configuration, reread the configuration either from the volumes or from the environment variable. So that way, dependencies on the gap that was there, what are the services Kubernetes provided and what is the Spring Cloud provided, there was like a gap for the integration of that, how we can interface that. That's why the community has modified this and it has been adopted as a part of the Spring Cloud product. So the Spring Cloud config server products are then so find the different configuration of the how the services can be featured, right? Uh, so how the load balancing should be done. So instead of for everything they need to go to the API server, they created a separate uh, component which actually limit the exposure of the API servers to only those components, not to the every service that are deployed to the big cloud applications. So configuration problem, as I mentioned, that how. it can be solved. Similarly, you have now, this is the modified version. Now, what is happened? The Spring Cloud config servers and Spring Cloud Kubernetes discovery servers. Those are now going to be interacting with your Kubernetes API server. So your config map can be either read from the config server can read from the config map or from Git. Okay, and then from the config server, the same your application can be read and you can actually refresh your configuration that is there. So instead of going to that, they have modified this, and also they have modified to the config watcher that was there, which can be used as a RabbitMQ. Similarly, now they have created a Speak Cloud Kubernetes Discovery Server. So in the Speak Kubernetes Discovery Server, what is happens? It basically then link up with the API server because API server has the detail for all the new services or ports that are coming up or crashing down or out. So they basically holds. So now you application can connect with the same way the Spring Cloud Discovery servers, and from there they can able to call without being overridden this detail the environment variable. Okay. Now this Kubernetes approach is more preferable when you are starting a greenfield app or you are starting a new microservices. Okay, and it can be considered provided you are deploying your application to a different platform. For example, you are moving from on-premise to cloud, or you are deploying some of your application to multiple or multi-cloud environment. So, for example, say your application currently is running on Azure, so we have to need to provide a support on the GCP. Now, obviously, the services of these two can be different, right? So you cannot depend on the platform services, but they both provide the support for Kubernetes. So in the so we can replace one Kubernetes cluster to the another Kubernetes cluster, or you are having like a native normal container, and from the normal container services, you wanted to move to Kubernetes cluster or Kubernetes container management. So from ECS to you wanted to move on AWS, say your Kubernetes service, right? So in those cases, you can consider this additional project of Spring to Cloud Kubernetes, which can be act as a alternative to better integration with the Kubernetes, which makes your application more cloud agnostic. Doesn't need to be depending too much on the cloud, apart from unless until you are using your native cloud services like for blob storage, etc. Okay, where the Spring also has an abstraction for those that you can also use, like Spring Cloud AWS, Spring Cloud GCP, Alibaba, or Azure to quick at doing those things. But Kubernetes help you to make you more or less, apart from native services, cloud agnostic or supporting multi-cloud or hybrid cloud strategies. So far, any questions? If not, we can go to the sample project code with details. Okay. So here you have like a sample project code. So let us look into the, it's a Maven project. So let us look into the basic Maven project. Here you have a different project. It's like a online shopping application. So you have your basic age service or gateway service. Then you have a hot deal service. Then you have a share which holding the product builder, and product categories, just the DAO objects. Okay. Then you have it like a toy based seller, right? Then you have fashion based seller and a config server and a discovery server. Let us look into the pop dot out here. So here you have a different models. Models have been added, and then you have Java version, and then Maven compile version, Spring Boot dependency version 2.5, and Spring Cloud version 2020.04. You can take the updated version, and then you add Spring Boot dependencies, then Spring Cloud dependencies, and districts has been added. Spring Cloud Actuator, Starter Web, Dev Tools, and test dependencies and Lombok. So this just the plugin for repackaging. Now here you have a different thing like a Docker project. Docker plugin is there, and you can create those repository details you can provide. Now let's look into the config server. So in config server, you obviously have the basic configuration dependency, the Spring Cloud config server. That is a simple service. There is nothing more out here. Just enabling the config service, a standalone Spring Boot service, and out here is reading its configuration from the particular Git repository. Okay, and in the Git repository, what we have here is basically the detail management endpoint. This. So detail endpoint. Spring Cloud Kubernetes by default is not enabled, it is false. Activate on the cloud platform Kubernetes, so it can be enabled. So only on the cloud framework, when it is like having like a cloud platform have been Kubernetes, then the Kubernetes cloud Kubernetes will be by default be enabled. The Eureka client has been disabled, and locally the Eureka client has been enabled for your discovery services, and for your local configuration it has been disabled. So two type of configuration conditionally going to be enabled. So you can run your application locally also, and then you can take the same application, deploy it on the cloud, and you can run them using on the Kubernetes platform across cloud platform on Kubernetes. And discovery services, for example, using a simple Eureka server based discovery for local development, and when it's going to the cloud, it's basically disabling it because there the discovery itself going to be provided by the Spring Cloud Kubernetes discovery server. Nothing much. Application properties just have the Eureka instances, localhost, client configuration, register the Eureka small, fetch registry false, Eureka instance hosts the server port and the Eureka details are there. And there is artifact that is present. Okay. Now let's come to the your gateway service. So gateway service is having same thing, enable discovery client. Okay. And here it is routing to the other microservices. One is the hottails, and it also has a circuit breaker enable as a kind of like a fallback function. So basically forwarding to the fallback server with the load balancer of hottails and passion based seller and the toy based seller. Okay. The fallback is doing nothing much. It's just setting a header fallback true and returning an empty list. Here also we have like a aggregator controller, a desk controller. What is doing? It's basically calling a function which is going to call the product response. So what is doing? It's using locally the web client, and it is basically for your start page. For example, for your main application or UI application, you have a start page where you can show the hot deals, fashion bestseller, and toy bestseller, right? So in that case, what going to happen is basically all the web client will be calling those hot deals, fashion bestsellers, etc. And it's also enable the client, which is your web client, and basically the URI is exchange and it is flat map. The response processor is nothing but which is handling the product response and it's checking if the header is fallback, then it is just simply returning an empty collection. If not, then it's converting the response from binary to flux, which is basically nothing but different products is returning, and those products are basically then converted to a list, and list is just flat map. It is just a mono product response class which having a response type remote service and the list of product. So this objects JSON is basically at the end of the day is been written. Okay. So and in case of an error happen as a startup page, new product response type is error, and the list is empty. So this has been added for all. In case of any error occurring, it just returning the error response. And then all the three datas from the three services have been fetched. They have been zipped together, okay, and they have been converted into a start page object, right? So basically, one single start page object has been created, and here is it has been zipped, right? So basically, the three different responses like get T1, T2, and T3 has been taken up as a product response, and then of the product response, the monos is basically setting the values out of here, and then it's stating the status response type, whether it is successful, whether it is failed, whether that is there, and the duration time for getting the request duration. Then on the app client, on the application event, This URL is localhost. Whatever event happened, client has been started when the application is been initialized. So the web server is basically initialized. Here, the class that has been created is the application listener, which is a web server initialize event. Then only the client has been initialized. Nothing much out here. Now, similarly, we can look into the other three services. Nothing but it has enable discovery client. It has a fashion bestseller. And the fashion bestseller, what you have is the atomic long product builder. It has just built normal sample data and returning it. Here in the resources, it same thing. It has like a Spring application detail and on Spring Cloud config server, it bit different because this is the like the service name. And it doesn't have much. It has actuator. It's a Unica client and test and swapping the default service or shared services stick. Same is with the other services that are there that we have seen. So now let's see each of the services, right? But for your discovery service or discovery client, right? That is going to be only used in your local servers, right? Rest of the cases, for example, in your gateway, right? Gateway depending on importing the configuration. So it's importing the configuration for the config server on Kubernetes platform. So it's basically each of the services that are there, they all are using this Kubernetes configuration server to getting the config. That is activated only when the Kubernetes is there. Locally, when it's running, is basically importing the configuration from the config server that is running on that particular port. So that's why not this config server and discovery server will be deployed to the Kubernetes. It will be only the gateway services and the other services will be deployed. Similarly, for hot deals, you have the same configuration and same for the Trojan bestseller. See, now here we have the config map, which is basically representing the toy bestseller, record some configuration information. It's storing the metadata about the toy bestseller, and it is having like Kubernetes config is equal to true. That is the only label that is currently is present. The rest of the services also have their own Kubernetes deployment file is there. So here you have the list of services. What is you have kind is a service, which is a application is a toy based seller. Name is the toy based seller. It's going to run on the HTTP port, and the target port is this. And toy based seller selector is base seller, and it's going to use the customer IP. Then it's going to be also watch the configuration changes from the Speak Cloud Kubernetes configuration watcher, and then they have like a role binding that is there, which is going to be integrate with the API service and the service account. Another is the configuration watcher. Same details are there. What are the rules that is there? It's going to listen to the resources like config maps, port, services, endpoint, and secret. And it's going to perform the operation get list and watch on them. And API groups, basically they're going to use app and extensions. Next is the deployment. It will be deployed with the label. So what it going to deploy? It's going to deploy the where the service level is matched to toy bestseller, and metadata is just the label app toy bestseller. And you had the spec with a config watcher, toy bestseller image pool, party present. It's going to pull that, and live bespoke that is there, and the port configuration is there. So similarly, we're going to find the same kind of a details for other services and the gateway. Having the details of separate port setup, those details are okay. Same for this service also. Any other questions?
No, sir.
Now, similarly, let's look into if you wanted to deploy this on AWS, right? So you have an app and you have a infra. So in the app and infra, whatever you have two main services that are there, or three services rather there, is this, right? So you have config watcher that going to watch the configuration and update that configuration via the HTTP call or via the event bus using RabbitMQ or other messaging services. Then you have Speak Cloud Config Server and the Speak Cloud Discovery Server. So how you can deploy that these things. So locally, if you wanted to run this, we can let's see if we can try to run this. So run this. So first your config server is up, okay, and it is running on the port 8888. Okay, let's try to up the discovery service. Okay, this is not recognized. Okay, there is some. Okay, we need to ensure the version. Search the appropriate version based on the Speak Cloud. 04 or discovery. Let's check. Nothing on the discovery service. Okay. 05, let me take that. 'Let us try to build this. Okay. Okay. In the meantime, let us go through this documentation. So it will take some time to get. Okay. So here we are deploying three different things. One is config server, config configuration watcher, which will be look into the configuration map, and configuration watcher, which will look into the deployment of things. And then you have a, like a discovery deployment. So let's just look into the config server deployment. So here you have like you are mentioning that in the config server deployment, you are coming to the list of items, the data which is having like application variable, which has the same configuration, but you have application variable is there. Now you're registering this as a config map, and you naming this service as a service which is having both app at the name level, Speak Cloud Kubernetes config server and Speak Cloud Kubernetes config server. Notice that. Then it's going to be done on this kind of a port. Obviously, now it will be choose. Now next thing is the load balancer, right? Now this thing require access to the API service. Okay, so service account, daemon app. So basically, it's going to be API version for RBAC, role-based access control for authorization of Kubernetes IO version 1. And here you have the role binding that is there. This is the labels and the role ref that it's what does is the namespace header, that is the name that is given, the role reference kind that's been used, and the API group is this API group they're going to be used. Another is the subject. What are going to be reading is this service account will accept this particular role, and then they have registered a role with the namespace reader, and they mention what are the rules or the services they wanted to access. Now the deployment side, they're going to be choosing the deployment of this metadata name in selector match label, what application they're going to be deploying this one. Template will be this, and the service account will be that particular service account name. Container name. Now, when you're going to be using this, right? So you have to build the Spring Cloud Kubernetes config server. Okay, that is 2.0.4. And that particular thing you need to be deploying into the AWS registry. So here is the DKR is the basically a particular account based registry that is there, and the particular config server version need to be pushed into there. So you have to, when you running this locally, that is okay. You are using config server or discovery server, but here you have to build the main source code and build that. And the port number, health, get endpoint, etc. and you will. Now, config watcher, here is the application variable that is there. It's going to be watching that particular configuration for the Kubernetes with the refresh delay of 10 seconds. And then it's going to be listen to a rapid queue service with a certain username and password. It's going to have like a certain log. Management endpoint, it's going to be opening up. That is the config map it's going to be registered with. That's it. And the deployment, it is added as a service. Similarly, you have the cluster IP, etc., service account, which is role bounded. The role reference, you're getting the role, you're saying which is the service account is related to that, and what kind of permission this will be requiring that. So that it will require all of these things. And then the deployment will be this template, bit data, etc. Service account container. Again, now here the image is available against the Spring Cloud. So you can use that particular image. You can pull the image and you can register that. So we can look into things available in Docker. Let's look into this. So here you can see that you can also use the Spring Cloud Kubernetes Docker Discovery Service, Spring Cloud Kubernetes Config Service, and Config Watcher of the Spring Cloud. So all these services are pre-built Docker images. If you wanted to use that or you wanted to custom build that, that's up to you. But we can listen to this, and then there are different X are there depending on the Spring versions. Like the latest version is 3.0.0 that you can use. Register basically snapshot. So you can use the image of all the three components that have been integrated to the Kubernetes. Same for config server, same for your config watcher. So config watcher here tag we can choose 3.0.0. So here the tag has been given snapshot. We can also put 3.0.0. Similarly for your config server, we can put the tag 3.0.0. And similarly for your discovery server, we can get the same detail. So all these services, three services on the infrastructure side, additional services that had the pre-built image are being loaded and used, they're going to be accessing the roles of with those permissions, with those resources on those firms, and they will be deployed as a service. As a deployment, which is defined as service as well as a service account. Now here the that has been done. Now you can deploy your application config map. So here you have put your application default configuration where you have exposed all the management endpoint like info, log, etc. trace. So you can define your config map using application variable. Then rest of the things like for example the toy bestseller service also have a like a secret along with the config map, right? Okay. So it's a configuration map, and here instead of variable, they have used the normal data with a key and value pair that is there. Similarly, for secrets, what they did, they put the upper queue this data, and the username password is there. And similarly, for your deployment, you have this as a service with this port, and then you have the deployment bestseller, and here you need to build this because These are not public images, so you have to build and you have to push to the container registry where your Docker images lies, and those things are then need to be pulled out from there. Similarly, for your gateway service, same thing is going to happen. Hot build service going to happening the same, and your toy based seller, we have seen that. Fashion based seller is also happening the same. We have a service and a deployment. Really, we need to define this service and deployment separately, but this has been defined in the singular class also. So, uh, if for any particular cloud platform, we can use the same kind of file. We can use the config server. We can use the config maps. We can use the config watcher for deployment, and we can use the discovery service. So these three services are actually currently going to be interacting with the API gateway. We define our config map, and in config watcher is having the watch facility. Similarly, they both have like a same kind of a services or roles that they are basically using. But these three images have been public, so they can be used. You don't have to build it and deploy that into their Kubernetes instance. And rest of your code will remain the same. Only thing is modifying for your services is that on the Kubernetes platform, in your resource file, you're just saying that I'm going to listen to from this config server because this config server is already registered and deployed with this URL. And this is like a service DNS within the Kubernetes network. It is not specific any IP address or any host name or public IP. No. Okay. So when the config server been deployed, the service itself has been given a name. And this is your service name. So from your application itself, you are mentioning this is my service name. Okay. And it's going to be activating on any Kubernetes platform. And the config server colon, this is the service name that I can import. So that's the basic three component through which it basically integrate with the Kubernetes, irrespective of any cloud environment. Okay. Any other questions? So, any other questions you have? If not, let us stop the presentation.